Hi, I'm Linda Eliasen. This project will analyze and fit a model to predict the number of monthly visitors to Yellowstone National Park. This information is important not only for revenue projections, but also for resource planning, both human and infrastructure. The data set being used has monthly visitor data from January 1986 through 2016. Yellowstone National Park is the world's first national park. It spans Wyoming, Montana, and Idaho. With a 45-mile-wide active supervolcano, hot springs, geysers, and wildlife, it is a popular tourist attraction for people of all ages. Visitors enjoy hiking, biking, horseback riding, and camping. The park hosts an impressive average of 3.8 million people per year. Looking at the plots for the data, there appears to be a seasonal cycle with a positive trend over the years. Sample autocorrelations at lags 12 and 24 are large and show sinusoidal behavior that doesn't appear to be damping towards zero. The spectral density provides further evidence with a peak at the frequency of 0.83 for a period of 12. Based on this evidence, the data is not stationary. The model was overfit to identify any seasonality in the data, and we can see here that the factors for a 1 minus b to the 12th are present. To obtain stationary data, the 12-month seasonality was removed, but the resulting charts do not appear fully stationary. Since there appeared to be a linear trend in the original plots of the data, the trend was removed and we can see in the bottom plots that it is now stationary. 6 models were investigated that covered 3 scenarios. The first removed the seasonal component, the second removed both the seasonal and trend components, and finally a stationary model was run without any transformation of the data. There were mixed results across the board in terms of AIC, BIC, and the L-Jung tests. However, based on the ASC results, there are 2 candidate models which you can see highlighted in orange in the last column. The first shown here is an ARIMA 10-1-3 with seasonality of 12. The second candidate model is an ARIMA 2-0-0 with seasonality of 12. The next step was to check residuals. While the ACF for both models indicate that the residuals appear to be white noise, only the model with the trend component failed to reject the null hypothesis of residual data under the L-Jung test at k equals 48. As we can see here, the same model also performed better in terms of the spectral density, while neither performed overly well from an ACF perspective. Based on the forecast, the model with the seasonal behavior and trend removed performed better from an ASE perspective. Based on all these factors, this model was selected to predict park visitors for the coming year. Shown here are the predictions of visitors to the park, which appears to be logical in that there are more visitors beginning in the spring and peaking during the months when school is not in session, and then dropping off after the fall. As this was a univariate analysis, the next phase of the project will be to include other factors that may influence people's visits to Yellowstone, such as weather and climate, travel costs, and other macroeconomic factors as shown here. Thank you very much for your time, and I look forward to sharing the next presentation with you.